So carrying on where we left off in part 1, this is characteristics of the graph of a logarithmic function y equals log x to the base b. Well, some characteristics are that the x-intercept is at 1. There is no y-intercept, so really what does it look like? It's looking like something like this, where this is 1. The y-axis is a vertical asymptote. So here's your vertical asymptote. This line is tending to follow the y-axis as it drops down. So y-axis is a vertical asymptote. The equation of the y-axis is x equals 0. Looking at the domain, that means the values, x values, are anything greater than 0. So from here onwards. So greater than 0, and all these numbers greater than 0 can be real numbers. The range for y, notice, as this continues on, it will continue up and out, and this goes down. So it will cover all y, negative y's, and eventually all positive y's. So it's a set of real numbers for the range. For this function also, it's equivalent to writing x equals b to the y. The inverse function basically of y equals b to the x, an exponential function. Where x is greater than 0, b is greater than 0, but with the added restriction that b cannot be equal to 1. b is the base of both the logarithmic function and the exponential function. This number down here is the base, or in exponential form, here b is the base. Note, since the logarithmic function y equals log of x to the base b is only defined for positive values of x, the logarithmic of a negative number cannot be determined. The logarithmic equation can be expressed in exponential form as x equals b to the y, and the exponential equation y equals b to the x can be expressed in this form. So if you have an equation y equals b to the exponent x, notice b is the base, y is the number that gets logged, log of y, the exponent becomes the value of the log. State the inverse of the following functions. Y equals log x base 3. And remember I told you if you need to convert, one way to write it is log x to the base 3 equal to y. And in this format you can drop the x down, swing the 3 over, bumping the y up. So it becomes x equals 3 to the y. Drop, swing, and bump. Okay? Drop, swing, bump converts a log to the exponential form. Except I think I've written it. However, so, then they want the inverse. So now we can switch the x and y's. We can write that as y equals 3 to the x. Okay? So either you can change the x and the y's here and do drop, swing, bump. So if this would have been y, it would have dropped it down here. 3 gets swung over and would bounce the x up. So I either do the drop, swing, bump first and then change the x and y's, or change the x and y's and then do the drop, swing, bump. Either way works. State the inverse of this function. This function would have to change the x and the y's. So you could do that first if you like. X equals 8 to the y, and now you could basically log by doing the opposite of what we've done here. The exponent becomes the value, This is the base, so really we're taking log of x, therefore, and the base would be 8. Same value here. Convert each of the following from log to exponential. Well, this is where you can use drop, swing, bump. Drop down the x, swing the 7 over, bumping the 4 up. Drop the 15 down, swing the 5 over, bump the y up. Drop, drop, and then we swing the t over, bumping the m up. This one, drop the 6, sorry, where are we here? Okay, with an added little technicality here, we should deal with this 4 first, because we just want a single log of a certain number. So let's divide both sides by 4, and we'll get 5 over 4 is log 6 base b. Now we can drop the 6 down, and the b comes over and bumps the 5 over 4 up. Okay, you drop, swing, and bump that up. And here's your answer. Now, example 6 here is convert the following from exponential to log form, which is the opposite. So remember, the exponent is the value that the log is going to equal. This is the base, so therefore we must be logging the 64. So it's log of 64 base 4 equals 3. So the number on the opposite side to the power is what gets logged. This is the base of 4, and the value equals 3. So it's just a way of remembering how to convert between one form and the other. Again, the value is going to be -3. Here's the base. Taking care of the -3, here's the base, so it must be log of an 1/8, with the base 2 equaling 3. Okay, from exponential to log. So here's exponential again. The value is going to be equal to d. Here's the base, and we're logging the f. Here again, we've got an exponential, so 5. Here's the base a, and we're logging the 2x plus 4. Example 7. Calculate the value of t if log x base 2 equals 3. Okay, we can use possibly drop, swing, bump. We can drop down the x, swing the 2 over, x is 2 to the 3, so x is just 8. If we're in this version here, again we can drop the t down, swing the 2 over, and it's to the exponent x. Now we're solving for calculate the value of t. Oh, okay, so what they're saying here, calculate the value of t if log x base 2 is 3 and log t base 2 is x. So notice we have converted this to the exponential form and solve for x. Now that we have x, we can substitute that over in here. So t will equal 2 to the 8 or 256. But that's using both this and this to figure out what t is. Okay, so we had to find out, first of all, because there's two unknowns here, two variables, we found x. We calculated x using this equation and substituted it into here to find t. Okay, the logarithmic form of y equals, so you should now be able to do questions 1 to 7 in the assignment. The logarithmic form of y equals ab to the x. So a little bit of summary here.